In this section of Arizona's complex water system, we'll examine Arizona's water balance. Sustainable water requires a long-term balance between water supply and water demand. We'll take a look at that, specific to Arizona. We've looked at Arizona's surface water supply system, from snowmelt through rivers, streams, and lakes towards the Sea of Cortez. We've also looked at the Arizona Canal System and Arizona's groundwater supplies. This chart from 2001 to 2005 indicates that a little more than half of the water used was from surface water, a little less than half from groundwater supplies, and then a small portion, around 3%, came as effluent water supply or reuse of our wastewater. The statewide effluent use of total supply is again only about 3%, but when you look at the total amount of effluent that we produce in the state, statewide we're probably using about half of that. Keep in mind, it is still only a small percentage of the total of the water supplies statewide. This graph depicts how our sources of water for the state have changed over time. The green bars represent groundwater and the blue represent non-groundwater or surface water and effluent. We can see that the use of groundwater has declined over time. At one point in time, back in the 70s, most of the water we used was groundwater. Today, we use more surface water than groundwater at a statewide level. One reason for this is that in early 1980, we adopted state laws trying to get people to be more prudent about their groundwater use. The summation of both provides an estimate of the total water demand, and although it has fluctuated over time, it has remained relatively flat. The red line represents population and its growth, so total water use has not really changed much, but at the same time, population for the state has grown. We've been more and more efficient with how we use our water, both for agriculture and for municipalities or domestic use. Thus, total water use remains relatively flat or unchanged. You may recall that we can classify water use as agriculture, domestic, and industrial use. On a global scale, more water is used for agricultural use than all other uses combined. Domestic use is close to a third that used for agriculture, and industrial water is close to half that of domestic use. How do we use water here in Arizona? In many ways similar to how water is used globally. About 75% of the water in Arizona is used for agricultural irrigation. About 20% is for municipal use or domestic use. About 5% of total water use in the state is used for heavy industrial use, such as copper mining. This use of water has changed over time as well. This graph shows that agricultural water use, the red in the graph, from 1970 to 2010 has been declining, while urban water use, the green, steadily increased from 1955 to 1995 and then began to flatten out. Industrial use has gone up and down during this period, but has remained relatively flat. This chart takes that same information and stacks it, showing total water use, which since 1980 has remained relatively flat with a slight decline, while population growth, the yellow line, has been steadily increasing. Where is the water used? Just as we saw varying global patterns of water use, the same is true for Arizona. The red areas overlying the state map are where water is being used for urban or domestic uses. The green areas represent agricultural water use. From this map, we see that much of the agricultural water use is concentrated in the central part of the state from Phoenix to Tucson, and the southwestern part of the state along the Gila River from Phoenix to Yuma and the Colorado River, and some in the southeastern part of the state along the Gila River and its tributaries. Urban water use is concentrated primarily around Phoenix and Tucson, with smaller areas of red spread around the rural communities of the state. There is a noted absence of much urban or agricultural water in the northern parts of the state. These spatial patterns of water use mean that water is used differently in different parts of the state. This graph shows the allocation of water used for domestic, blue, agriculture, green, industrial, gray, and power production, yellow. In the west and southeast, agriculture dominates the use of water. In the central south, Phoenix and Tucson corridor, agriculture represents about 2/3 of the use, and domestic 1/3 of the water used. In the central, north, such as Prescott and Verde Valley, water use is allocated equally between industrial, agriculture, and domestic uses. In the north, power production has been the dominant use of water, with domestic representing about 1/3 and agriculture about 1/4. This will likely change in the future with the closing of the Navajo Power Station. Even at a county level, within these regions, the use of water can be spatially different. This chart shows agricultural and domestic water use for Maricopa, Pinal, and Pima counties, all within the central south region. Here, Pinal County is almost all agricultural water use, while in Maricopa it is close to 50-50, and in Pima County it is almost 70% domestic water and 30% agricultural water use. So how do we compare in our water use to other states? This figure shows per capita water use for 13 states. There is much variability in GPCD across these states, with Nevada having one of the highest per capita water use to Alaska, which had one of the lowest values reported for 2005. Arizona is fairly close to the middle. It's not the worst, it's not the best. One might think that maybe northern states would have less GPCD than southern states, but Idaho is a northern state and it has a pretty high GPCD. Colorado uses less water per capita. But New Mexico has a fairly low estimate. It's one of the lower estimates for these states. This is not necessarily related to climatic conditions. Climate does have some impact on per capita water use. For New Mexico, it's more about how the water is being used. It's not so much what the climate is. We've seen some decline in GPCD for Arizona, and if we continue this trend, GPCD will go down to about 118 by 2050. Is it possible for GPCD to go too low? This chart gives you an idea of some of the things you'll have to do in order to reduce GPCD to below 118. The trend of 118 is really just a continuation of the existing trends in terms of continuing efficiencies over time. For example, we're going to see people having less outdoor water use. We're already seeing less fountains and less grass. Golf courses have already started to adapt. New households and renovations of older structures include high-efficiency fixtures. But what would we have to do to get even lower than that? Let's say we wanted to go down to a GPCD of 90. Then we would have to greatly reduce how we use potable water for irrigation and move to really ultra-low water use of plants everywhere? What if we wanted to go down to 70? Well, we'd have to eliminate almost all outdoor water use. Nobody can have grass, we can't have misters anymore to cool off, and we won't have trees for shade. What about a GPCD of 50? We would have to look greatly at reducing non-residential water use. Industries would have to switch from water-cooled systems to air-cooled systems. What would we have to do to get down to 30? Well, we'd have to force water budgets on people, and we're only going to be able to have essential non-residential water uses. We'd have to focus on only those uses that are critical to society and survival. This concept of ideal efficiency is captured in the WaterSim user interface. Using the efficiency of water use indicators, we can see that ideal efficiency is captured in the green range. Water use is a careful balance and full of trade-offs. On the left, an indicator of very high efficiency will mean people are giving up a lot. Meanwhile, on the right, if you have a little water efficiency, then you are draining your water outputs in order to keep high levels of comfort. The key is finding somewhere in the middle where comfort is not completely sacrificed, but water is also being saved. This can be done by exploring different policy choices in the model. There are a lot of unanswered questions about the future of water demand. Agricultural water use has been declining slowly in Arizona over the last 50 years, but prior to that it was increasing. It is not clear what will be in the future. Agriculture could continue to improve the efficiency of water needed to produce a unit of product, thus it would continue to decline. If this will happen and how fast is uncertain. The same is true for domestic water use. Will it continue to decline? Is there a limit on how low water use can go before it begins to affect the economy or quality of life? We have been in drought for almost 20 years. Will that continue? Will increasing heat and declining rainfall require more water to water our landscapes? All these questions bring a great deal of uncertainty to our thoughts about the future of water demand. Uncertainty about the future is not the only reason planning for water sustainability is difficult. Water gets used for many different purposes and in many different ways. Each purpose has its own unique context and issues, and the people managing water for each purpose have a different viewpoint on how water should be managed to be sustainable.